Okay guys, so today we're going to learn how to solve an equation with two exponential functions set equal to one another. So let's start out with an example here of 5 times 1.05 to t, and we want to know when is that equal to 10 times 1.01 to t. So you can see here that we have a smaller initial value, but growing at a larger percent, right? 5 to the 1 times 1.05 to the t, and then we have 10, right, but growing at a lesser percent. And we know that t is going to be positive here because both functions are increasing. So eventually, the one with the 5 in it will catch the other one. So we need to figure out what t to use here. You already know how to do this on your graphing calculator, right? But now we're going to look at how to do this using logarithms. There are two basic ways to attack this. You can take the logarithm of both sides first, or you can divide first. Whichever method, I'll show you both ways to do this. It's totally up to you which way to pick. Some students find number 1 easier, some students find number 2 easier. Let's take a look at number 1, where we take the log of this equation, log of both sides first. So the first thing we're going to do here, as the name implies, is take the log of both sides. So we have the log of both sides. Now we see that really what we have here is the log of 5 times 1.05 to t and the log of 10 times 1.01 to t. That means we can use the product rule. And that turns into the sum or addition of logs. Okay, so you can see that we've broken apart these pieces just a little bit. Now we have to go ahead and move all of our t's to the same side. We can do this in two ways. The first way, and probably the easiest way, is to use our power rule to bring both of those t's down out of the exponent. So that would give us log of 5 plus t log of 1.05 equals log of 10 plus t times log of 1.05. So now at this point we have a linear equation, right, with a t on both sides. And just like we've always done, right, we're going to rearrange this so that both of our t's are on the same side. Okay, so what I'm going to do here is move everything that's a constant, so log of 5 and log of 10. Right, I'm going to move those to the other side. And I'm going to move all the things with a t in it to the left-hand side. So I'm going to subtract log of 5 from both sides. And I'm also going to subtract t log of 1.01 from both sides. So you can see here that we get cancellation here and cancellation here. So we end up with t log of 1.05 minus t times the log of 1.01 equals the log of 10 minus the log of 5. Okay? So that gives us a pretty tricky equation still, but there's only one more step. So there are two more steps. What we have to do here is get both of these t's into one. So we're going to factor t from both parts. Okay? So now we have to solve for t, we're trying to get t by itself, we have to divide by this whole long string of numbers. So we get log of 10, which of course you know that log of 10 is really just 1. So we can cancel this out and put a 1 in its place. So our answer here is 1 minus log 5 divided by log of 1.05 minus log of 1.01. Now, if we take our calculator, so using our calculator, we get a value that's approximately, you got to be really careful with your parentheses here, grouping what's on top and what's on the bottom. Right, we end up with about 17.85, whatever that means. Okay, now in some cases, I want to know the decimal value, like if I'm dealing with an investment. But here, right, I actually might want to leave this algebraically as all those logs together. Okay, so that's method 1, where we take the log of both sides first. Let's take a look at version 2, right, where we, instead of taking the logs of both sides first, we divide first. So here's our original equation. Let's divide both sides by 8. So let's divide this side by 5 and this side by 5. Of course, that cancels out my 5's here. I'm left with 1.05 t equals 2 times 1.01 t. Then we can divide both sides by 1.01 to the t, which of course cancels out. And then we're left with 1.05 t divided by 1.01 to the t equals 2. So we've already, this way is a little bit quicker in some ways because you already have your t's on the same side. The next step is a little tricky, but really it's a pretty simple application of the distributive property. So we're going to undistribute that t and get 1.05 over 1.01 to the t equals 2. Now at this point you say, well, Mr. Minnich, the t is still in the exponent. And I say, well, you know how to get that t out of the exponent. And the answer, of course, is log. So we take the log of this side and the log of 2. And that's going to give us t log of 1.05 over 1.01 equals the log of 2. So again, using our power rule here, this is our power rule. Okay? And then to get t by itself, we simply divide both sides by this whole big thing, and we get log of 2 over log of 1.05 over 1.01. Again, when you put that in your calculator, you should get about 17.85. Okay? So 2 equally good ways to do this. Just pick whichever one you prefer. I think a lot of students prefer way number 2, which is dividing first. It's not always so nice as this, though. You don't always get a nice value like 2. Sometimes you get a terrible decimal, and it's a little harder to work with. It's up to you which way to choose. Choose one of them and do your homework. Good luck.